Hello everyone, thank you for joining today in attending this session. Today we are going to talk about how Bloomberg invested in smarter search with Amazon Kendra. I'm Ritesh Vajaria, I'm a Principal Solution Architect at AWS, and today we are joined by Tommy Shen. He is a Machine Learning Team Lead at Bloomberg Industry Group. From agenda point of view, these are the things we're going to cover today. We start with AWS machine learning stack. We'll give you a quick introduction into Amazon Kendra. We'll talk about how the smart search is applied in using Amazon Kendra. We'll then pivot into what Bloomberg Industry Group is doing and how they are applying Amazon Kendra, what they were doing before Kendra, and what is the life after Kendra. What are some of the business benefit we're going to cover as a part of that, and eventually we will review what's next for Bloomberg Industry Group related to Kendra, and we'll wrap it up with how easy it is to get started with Amazon Kendra. Okay, with that, let's dive deep. Okay, businesses are generating more data than ever before. But even though we have more and more data, it's not always being used in the way that helps us. One reason for this is that a lot of data that's being generated is unstructured and spread widely across the organizations, making it difficult for all users. So this information is not meaningful and employee cannot find it very easily. In fact, being able to make sense of the data and optimize for relevant information as opposed to distracting or unhelpful information is something society as a whole, not just businesses, can relate to. But what's blocking us from achieving that goal? A number of things actually. Conventional solutions for creating great search experience have fallen short. And when we consider the plethora of data that exists, that is growing, and that resides in the scattered systems, we can rest assured that the existing tools won't help us create the search experience we will need in the future. Keyword-based search, for example, won't deliver the accuracy that's needed and are ineffective when searching the information in unstructured data. Better search is a fundamental need for virtually every industry, whether it's to reduce the manufacturing timeline or to accelerate drug development or global research efforts. Making sense of data and getting to the relevant information faster is very crucial. With that in mind, at AWS, we deliver a solution to this problem. We applied machine learning to solve this problem and delivered better search for organizations of all sizes. We developed Amazon Kendra, an intelligent search service. Amazon Kendra sits at the top of ML stack. What you see on your screen is a machine learning stack at AWS, and Amazon Kendra sits at the top layer. And remove the undifferentiated heavy lifting so your team can move faster and deliver exceptional search experiences so customer and employee find the relevant information very quickly. So let's look at how it does this. Amazon Kendra is an intelligent search service powered by machine learning. Kendra reimagines enterprise search for websites and applications so employees and customers can easily find the information they are looking for, even when it's scattered across multiple locations and content repository within an entire organization. Kendra solves two key problems our customer consistently reported using either commercial or open source search solutions. One is the low search accuracy, making it easier and faster to find better answer. And the second thing is complex implementations. Simplify the implementation process. Our native connectors playing a key role in the streaming content and the security aggregation. To increase search accuracy, reduce total cost of ownership, and improve user experience, Kendra uses NLU, a natural language understanding, and multiple machine learning model to run both keyword and natural language queries that identify concept, entities, and semantic relationship in text, and using models like reading comprehension that extract the answers directly from the text. Intelligent search can be a complete replacement or run side by side on a traditional keyword search engines. Keyword search just bring back the document ranked on a very rough and inaccurate match of the query keyword without understanding the language nuances within that. And this is why you typically need to click on several documents on several search results page looking for the answer before you complete your search task. With Kendra, whether you are using a keyword or a natural language query, Kendra understands your intent and can extract the right answer right on the search result page. And you are done with your search, no clicking through the documents, saving valuable time for you or your customers. By moving from traditional keyword search to intelligent search powered by machine learning, our customers tells us that they gain search accuracy, lower their total cost of ownership, as well as using the Kendra as a fully managed service, they delight their employees and customers with internet-like search experience. We see customers finding the advantage of intelligent search across many areas of their businesses. Some are accelerating research and giving development teams better search experience, helping them to tap onto the mission critical information and shorten their time to market. Other organizations are lowering regulatory and compliance risk, preventing the likelihood of getting a legal cost further down the road. We also see customers using better search technology like intelligent search to enhance conversation with customers or assisting in a call center like setup so that accurate information is delivered to that agent so that they can make a meaningful and efficient customer interaction. You may have seen quite a lot when you interact with the chatbots. That is one of the examples we can think here. Some of our customers like Wall Street Journal, they are helping customers to find the content they care with more relevant search and richer website experience. So how easy or difficult to get started with Kendra? In fact, it's very easy. It's just 3 steps. In step 1, you create an index. An index is in place where you add your data source to make them searchable using Amazon Kendra. Step 2, you add and synchronize your data source. There are multiple places from where you can sync them, such as S3 from a simple storage services point of view. If you have a SharePoint, like you can embed that as well. Or if you have any other databases, that works well as well. And step 3, once your data is synced, go to the Search Console and just test and deploy the Amazon Kendra in your search application. It's as simple as these 3 steps. So let's dive a little bit into the core capabilities that address accuracy. Right? We touched upon accuracy briefly in the earlier, but let's see how Kendra does it. So Kendra provides a more intuitive way to search your data. Natural language questions provide more clarity and more precise answers. And keyword search are supported as well. But natural language queries allow Kendra to hone on specific concept and attribute that user are actually searching for. Better enterprise search is all about providing better answers. To deliver this, Kendra uses three core components. The first is reading comprehension, which understands the concept in the text, whether it's a person, an organization, a location, a quantity, a date or time, and then it extracts an answer based on the semantic or the meaning of that query. Number two, FAQ matching or frequently asked question matching. And that matches the similar and curate the FAQs to user queries and provide authoritative answers without the need to sift through the FAQs. And the third one is document ranking. Document ranking that returns the list of links to the relevant document based on the meaning of the query. And it improves the relevance in document search compared with a keyword search. And that does not take, because keyword search does not take the context in account, versus in this intelligent search, you get context awareness as well. In order to understand the user query and the text-based answer, Kendra's models are pre-trained on a number of domains that can associate domain-specific terminology within the user query and also the text, and produced in a contextually relevant manner. Amazon Kendra also includes continuous improvement. So it's a feature that ensures that search results are always accurate and relevant over time. This incremental learning comes built in to Amazon Kendra, and it learns from the user interaction and the feedback. It uses the input to reprioritize content in the list of the search result, so that over time, the information that proves to be the most valuable based on a user question or based on a number of users is positioned at the top of the list. Connectors. Using connector is very quick and easy. You just add data sources to your Kendra index and select the connector type, and boom, you are done. Connector will always maintain the document access right. You can also schedule in an automatically sync with your index of your data sources, or always the security, we take care of that. And the data is always securely searched through the most up-to-date content. Talking about security, security is job zero at Amazon. And Amazon Kendra delivers highly secure enterprise search for your search applications. Your search result reflects the security model of your organization. Customers are responsible for authenticating and authorizing the users to gain access to their search application. At the search time, the Kendra service filters the search result based on the user ID provided by the customer's application and the document access control list collected by the Kendra connectors during either the crawl process or the indexing process, and it applies that. The search result returns a URLs, and they point back to the original document repository plus the short excerpts. Access to the full document is still enforced by the original repository. So if user doesn't have access to the original repository, user would not get access, and we take security at a very high. From a data encryption point of view, with Amazon Kendra, your data is always encrypted in transit using HTTPS, TLS, and even at rest, you can encrypt the data either using customer managed keys, or you can apply using AWS provided keys. Amazon Kendra also support the token-based access control using OpenID or JWT tokens with a shared secret, or JWT with a public keys, or your JSON token types. there are various mechanisms which you can apply for your access control. And customer can securely pass that user access information in the query payload. So Amazon Kendra at the end can validate your token information and automatically apply it to your search result for accurate and secure access-based filtering. Many organizations across multiple industries are migrating to a more intelligent search experience to give customers and employees more relevant information and to drive positive outcome that they would receive with the traditional search experience. Here are some of the names what you see on your screen, but let's hear it from a customer who is here today and hear from them itself how they are using Amazon Kendra and going further along with. With that, I'm going to hand it off to Tommy Shen from Bloomberg Industry Group. Tommy, please take it over.
Thank you, Ritesh. That was a great introduction to Amazon Kendra. I'm thrilled to be here today sharing our team's experiences with it. I am Tom, the machine learning team lead with Bloomberg Industry Group. So I'm sure almost everyone here has heard of our parent company, Bloomberg LP, and its flagship product, the Bloomberg Terminal. And in very much of the same spirit as the Terminal, Bloomberg Industry Group, a subsidiary of Bloomberg LP, seeks to empower professionals in the government, law, and accounting space. Our goal is to be absolutely essential to our customers and cater not only to their current research and data needs, but to anticipate their future professional requirements for information and analysis. To accomplish this, we essentially become hoarders. Our platforms contain petabytes of primary source documents, reference materials, analysis, and news. And behind all of that are teams of engineers, data professionals, content specialists, dedicated to hoovering up publicly available information and enriching it for our customers. We are continuously adding new content and growing the value proposition of our product for our customers. So our team was formed in late 2019 with a charge to develop machine learning solutions for our product platforms. The team consists of one data scientist, that would be me, and two software engineers, and we operate very much like a startup within the company by design. And like any good tech company, our product managers are ambitious and forward-looking. Our backlogs are filled to the brim with technological aspirations and experiments. Yet, the day-to-day realities of keeping multiple platforms online and flowing with data means that resources available for validating product concepts are sometimes scarce and research runways are short. Our team's design is to research, prototype, and deliver with less resources and shorter runways. To do so, a core strategy for the team was to evaluate existing machine learning solutions, both inside and outside of our organization, and see if they can be used to tackle any of these existing product aspirations and experiments. So this talk focuses on my team's experiences with implementing Amazon Kendra for Bloomberg Law. And to give you a little bit more information about Bloomberg Law, as the name suggests, serves a wide community of legal practitioners. Our motto is one platform, one price, continuous innovation. This means that all new content and features that we continuously add to our platform becomes available to our customers at no additional charge. We can boast that we can count 95% of AmLaw 200 firms and 48% of Fortune 500 companies as our customers. So having given you the context of what my team does and the parameters that we operate within, I wanted to rewind 2 years to a few weeks right after my team was first formed. And one of our first activities together as a team was an online watch party for AWS reInvent 2019. Having just come into existence, we missed the train to sign up to attend in person, and so we all huddled together and watched online. This was the event at which Amazon Kendra was announced, and the service quickly made it onto our look at list. Coincidentally, a few weeks later, we were asked by our executive team to take a look at the service as well. So it naturally floated to the very top of that list. And the question that my team tried to answer was, can we use Kendra to tackle an existing product aspiration? So we started to play and experiment, and the very first thing that we noticed was that Kendra is shockingly easy to deploy and configure. I think at the very beginning of this experiment, we had allotted ourselves about a week tops to get Kendra up and running. And we had shockingly spun it up within 40 minutes. And we had it online so quickly that we hadn't even figured out what the data we were going to test it on was yet. And as we started to throw various data sets against the wall, we realized the extent to which Kendra was a full-featured search service. Depending on which component of Kendra you intended to leverage, you can incorporate different search strategies in your product design. And you can lean on, or you can lean into question and answering, or you can implement Kendra that much closely resembled a traditional document search engine. And the critical feature that informed our next steps forward was that Kendra performed very well retrieving facts. Over the course of our experiments, we indexed everything from news articles to regulatory agency announcements to legal decisions, anything that we could basically get our hands on. And of the data that we used, Kendra performed the best on reference documents with high information density. And what that means is documents with lots and lots of facts and not a whole lot of analysis or ancillary text. So based on this information, we found a pretty good opportunity to enhance one of our most popular existing products, chart builders. Our chart builder product allows customers to look up and compare rules about a particular legal topic across several jurisdictions and output them to a chart. The way it works, as you can see on the left hand of the screen, is that a user selects the legal topics they are interested in, along with the jurisdictions they would like to look up the information for. They click Generate, and they get a tabular result that displays each state's rule in each cell. The data within these cells are created by our subject matter experts and consist entirely of factual information, references, citations, and not analysis. One thing you'll observe here is that utilizing this tool requires you to know which section header or topic your answer falls under. This is a fairly simple ask for experienced users of our product, but not for new customers. So chart builders are great when you need to compare rules across jurisdictions, and if you have expertise in this content already. But chart builders tend to be a little bit cumbersome when you just want to look up a quick fact about a specific state. And based on usage observations, most interactions with chart builder take place between 6 to 30 clicks, depending on how complex the chart needs to be. For many users, this is simply not how modern users interact with information. Users these days expect to search for answers, and they expect searches to deliver answers and not documents. Our existing search solution generally does a great job of finding the right document these answers are in, but reference documents tend to be lengthy and dense and really dry to read. In fact, in one meeting, we heard that it was compared something akin to warm milk. Using this paradigm, would force our users to read through said dense document to find their answer. Our engineering teams have tackled this problem a number of times in the past, but most efforts have really relied on the previously referenced expertise with the product. Our last attempt looked for exact matches between user queries against the jurisdiction and section titles of the chart builder. And if that exact match was found, the prior solution would return the information in the correct cell. But if there was no exact match, it would not return anything. So the reason Kendra might be a good fit to tackle these existing problems is that allowing our users to use natural language search over this content helps to bridge that expertise gap. We could also tune it to translate legal jargon into plain English and vice versa, expanding the accuracy and relevancy of our potential search results. Our Kendra implementation allowed us to offer users the exact document sections and paragraphs relevant to their query without having them wade through thousands of lines of reference text. But that's all nice and good. At the end of the day, though, the product question for us is this something our users want? Is this how our users want to access this information? And the reality is that we can do as many mockups as we want, but hard usage data speaks much, much louder. Hard usage data requires you to build the solution, and most approaches to build such a solution takes months of research, development, and testing. Amazon Kendra significantly shortened the research and development cycle of this experiment for us and allowed my team to focus most of our time on testing instead of building. So I want to give you a little bit of an overview into the various components of Kendra. And Kendra results come in three parts. One is the answer you see at the top. This is the question and answering service that allows Kendra to return a natural language response to your question. The second section, labeled question answer, is the FAQ matching that similar to curate FAQs to user queries and provides authoritative answers without the need to sift through those FAQs. And the last is a document ranking list that returns not only the document, but the snippet Kendra feels is the most relevant to the query itself. And so we encountered, unlike any tool that you use off the shelf, we encountered a number of challenges and gaps within the Kendra service. First of all, most of the tuning mechanisms available to us targeted only the document results. And as you remember from the previous slide, the document results is the list of documents relevant to the query. These tuning mechanisms can be amazingly effective at the document level, but our use case went much, much deeper. We wanted to return the answer from within that document that best corresponded to the query. Some of the issues and challenges on our side was that our language is highly repetitive and boilerplate. In many, many sections, we would have the exact same text between several states, except for the fact that the state names are changed. Our content also contains many technical terms and specialized language that is sometimes difficult to understand for a search engine or an inexperienced user. So we devised a number of workarounds. And based on our implementation, the biggest aha moment for us was that the data we index doesn't necessarily have to be the exact same as the data we presented in its final form. Based on this insight, we split our data into two branches. One was the original content that we would index and store in Amazon DynamoDB. The other would be the scaffolded text that we indexed with Kendra. And what I mean by the scaffolded text is text that consisted of the original content, but also enhanced with additional text to help Kendra better understand exactly what that section was about. And to help reference that original content in Dynamo, we added anchor links to each section of the documents we index with Kendra so that the user is never exposed to our additional data enhancements. After all, they might be wrong. We additionally bridged the language and legalese gap with extensive synonym lists that we created and borrowed from other projects, and added additional context to each document via metadata fields that also factor into the relevancy tuning that I previously described. And finally, we would not be a machine learning team if we did not approach testing in a machine learning way. Because we created anchor links within each document section, we were able to create question-answer data sets to test our Kendra implementation and determine the best next steps for tuning Kendra. So here, I would like to give you an overview of our simplest Kendra implementation. I'm going to start in the far left, where a user queries our platform, Bloomberg Law, which then transmits that query and calls the Amazon API gateway. The API gateway then passes that query to Lambda, which first queries Kendra and gets a result set back. Based off of those results, our implementation in Lambda then looks up the appropriate section of text, which is already indexed in Amazon DynamoDB, and presents that final document to the user. On the right-hand side, we are currently using a local server to parse and create the documents that we would feed into both Amazon Kendra and Amazon DynamoDB. And for our future implementations, this is one area where we would love to leverage the AWS machine learning stack and move this fully to the cloud. So the end result is that our team was able to successfully launch fast answers for the state labor and employment chart builder product in October of this year. And the goals of this beta is to see just how users interact with the tool. See if they get the wrong answer or an answer that they're unsatisfied with, how many times they change their query and try again, or if they just abandon the tool entirely. And based on these observations, we hope to identify the areas where we can make the appropriate improvements and answer that product question. Do our users actually want to interact with this information in this way? Our team is also currently working to extend Amazon Kendra to other content sets for our other platforms. So with this, I'll turn you over to Ritesh for a call to action.
Wow, Tom, that was amazing. What a story, what a story. Thank you for sharing with us. Folks, as Tom said and as they experienced, getting started with Kendra is super easy. As we discussed earlier, it's a three-step process. Step 1, set up your index. Step 2, set up your data source. And 3, query your Kendra queries right away. So it's super easy. There are tutorials available for you to guide through the entire process. There are videos which shows you how to do it step by step and how to use connectors and many other functionalities. With that, go build.